All right, so what does this example tell us? It tells us that when we are calling functions and we are passing arguments into a function, it is important what type the arguments of that function have, and that the values that we are passing into the function adhere to the same types that are specified in the function signature, more precisely in the argument list of the function. So we need to be sure that the arguments that we are passing into a function have the correct type. All right, and since we're talking about the idea of passing functions as arguments into other functions, and we just noticed that it's important that arguments have the right type, it is natural to ask, what is the type of a function then? So if all the arguments that we're passing into functions need to have some kind of a type, and we want to pass functions as arguments, we need to know the type of the function that we want to pass. So let's figure out how we can find out the type of a function. So here as an example, I want to consider the add function again that we saw on the previous slide. And if we wanted to find out the type of this add function, the first thing that we have to do, we have to only look at the function signature. In fact, we only have to look at the argument list and the return type. And once we've done that, we can just remove the argument labels, and then we end up with what is the type of this function. So the type of the add function here would be int to int. And the way how we say this or read this out loud would be that we're saying the type of the function add is from int to int. So that's the way how we are saying the type of a function. All right, but watch out for special cases though, because what happens if we don't have arguments or if we don't have a return value? Well, if we don't have arguments or if we don't have a return value, then we're replacing either the argument list or the return value with the keyword void or with an empty pair of parentheses, but we still have to keep the arrow. So for example, a function that would take in two strings and returns nothing, this would be a function from string to nothing, and we still have to keep the arrow in the type of the function, but we're replacing the return type by an empty pair of parentheses. We might as well replace it with the keyword void. Or if we have a function from void to bool, then in this case we would have a function that takes no arguments but that returns a Boolean value. And here again we could exchange the keyword void for the empty pair of parentheses. So these two are 100% equivalent. All right. So next I want to do a quick quiz with you guys. So I've prepared 3 functions, which you see on this slide here. And I'd like you to pause the video right now, take a pen and a sheet of paper, and write down the types of these 3 functions. All right, so hopefully you've got the types written down now. So let's figure out what the type of the first function greet is. So we see that the function greet takes in a string as an argument and an array of strings, and it's going to print all the names along with the greeting. So all the strings from the array along with the greeting string. All right, so let's take a look at what the type of this function is, and hopefully you figured that it's from string array of strings to void, because we don't have a return value here, and the function takes in a string and an array of strings, and equally valid as an answer would be from string and array of strings to the empty pair of parentheses. All right, the generate random integer function is of type void to int or empty parenthesis to int. You can write it as you like, as you prefer. This function doesn't take any arguments and returns an integer value, so clearly its type is from void to int. All right, and finally, the last functions that we had was called generate and print data. And as the function doesn't take any arguments and doesn't return any arguments, you can basically write void void or empty parens to empty parens, wherever you like. And this is the type of the third function.